Okay, so these video notes are over multiplying and dividing rational expressions. So to review, to be able to do this, we need to know how to simplify rationals. So if I'm simplifying x squared plus x minus 6 over x squared plus 4x plus 3, I first need to factor everything. So x squared plus x minus 6 factors to be x plus 3, x minus 2, over, in my denominator, x squared plus 4x plus 3 factors to be x plus 3, x plus 1. And now if I have any identical factors in the top and the bottom, I can simplify those out, which I have an x plus 3 in the top and the bottom. So this simplifies to be x minus 2 over x plus 1. Also, to state our excluded values, you take your denominator, so x plus 3, set them equal to 0 and solve, because we're looking here for what values make our denominator equal 0. So x should not equal negative 3 and negative 1. Now, multiplying rationals are just nasty fractions. So when we multiply fractions, we just multiply straight across. Well, here with rationals, yeah, we can multiply straight across and do a lot of foiling and box method, but you're going to have to simplify, and that's going to be really, really difficult if you just multiply everything together. So the best way to approach it is to factor everything and then see if you can simplify any like terms. So here I have 4x squared minus 4x over x squared minus 4x plus 3 times x squared plus x minus 6 over 4x. So my first step is I'm going to see, can I simplify everything? So 4x squared minus 4x, there's two terms. So I'm going to see, do those two terms have anything in common? They do, because I can factor a 4x out. And if I factor 4x out, I also have x minus 1 over x squared minus 4x plus 3 factors to be x minus 3, x minus 1. Then I've got times x squared plus x minus 6 factors to be x plus 3, x minus 2. And then I've got over 4x. Because this is multiplication, I can go ahead and just extend this division line all the way across, because everything in the numerator is going to get multiplied and everything in the denominator is going to get multiplied. So now I'm just going to look, is there anything identical in the top and the bottom that I can get rid of? Well, I see that I have an x minus 1 in the top and the bottom. I also have a 4x in the top and the bottom. But that's it as far as what is identical. I have an x plus 3 in the top and an x minus 3 in the bottom, but that is not the same thing. So I'm left with x plus 3 times x minus 2 over x minus 3. Okay, and just leave the terms factored like that. You don't have to FOIL it together. Now, when you're talking about excluded values, you have to use all of your denominators. So I would do x minus 3 equals 0, x minus 1 equals 0, and 4x equals 0. So you have to use all three. So here I would add 3. So x should never equal 3. I'm going to add 1. So x should also never equal positive 1. And 4x equals 0 divided by 4, so x should also never equal 0. So I have three excluded values of 3, 1, and 0. And I simplify to be x plus 3 times x minus 2 over x minus 3. Next one, I have 3x minus 3x squared over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. So I'm going to see, can I factor everything? So 3x minus 3x squared, I can factor out a 3x. I can factor out a 3x. They both have a 3x in common. And I'm left with 1 minus x over x squared plus 4x minus 5 factors to be x plus 5 x minus 1. Then I've got times x squared plus x minus 20 factors to be x plus 5, x minus 4, and then over 3x. All right, it's a multiplication problem, so I can just extend my line all the way through. So make it one big division problem. And now I'm going to look for any identical factors in the top and the bottom. So there is a 3x in the top and the bottom. There's also an x plus 5 in the top and the bottom. And I'm going to take a step back and look at what I've got left. So I'm going to rearrange this one to be negative x plus 1 times x minus 4 over, I've got a positive x minus 1. So looking here, I've got a negative x plus 1. I don't like having a negative x, so I'm going to rewrite that and make it a positive x. So first I'm going to factor out a negative 1, and that'll make that a positive x minus 1, and then times x minus 4 over x minus 1. And because I factored out that negative 1, I found one more identical factor. I've got an x minus 1 in the top and the bottom. So I end up with, you can write it as negative x minus 4, or you can write it as negative x plus 4. I'm probably going to be writing it like that. Now, for our excluded values, you're going to use all three of your terms that are in your denominator. So you would do x plus 5 equals 0, x minus 1 equals 0, and 3x equals 0. So subtract 5. So x should never equal negative 5. Add 1. X should also never equal positive 1. And divide by 3. And x should also never equal 0. So we've got three excluded values of negative 5, 1, and 0, and we simplify to be negative x plus 4. Dividing rationals is, we approach it the same way that we've done dividing fractions. So when you divide fractions, you copy the first fraction and you multiply by the second fraction's reciprocal. So you just flip the second fraction. Same thing here. So 2x over 3x minus 12 divided by x squared minus 2x over x squared minus 6x plus 8. I'm going to factor everything, but before I do that, I'm going to do copy dot flip. Actually, I can go ahead and combine steps. So I'm going to factor as I go. So 2x, I can't do anything else to. Over 3x minus 12, I can factor out a 3. And I'm left with x minus 4. I'm going to multiply it by the second fraction flipped. So I'm going to be dealing with the x squared minus 6x plus 8 first. So I'm going to factor that. So factors of positive 8 that add up to negative 6 are x plus 4. I'm sorry, no. X minus 4 and x minus 2 over x squared minus 2x is going in the denominator, and I can factor an x out of that, and this becomes x minus 2. Now that it's a big multiplication problem, I can just extend my line across, and I'm looking for identical factors in the top and the bottom. Well, I've got an x minus 4 in the top and the bottom. I've got an x minus 2 in the top and the bottom. And if I'm multiplying straight across, I've got 2x over 3x. These are not being added or subtracted. It's all multiplication, so I can actually simplify out the x's. And I get 2/3. So 2/3 is my simplified rational. I still need to talk about my excluded values. And when I'm doing my excluded values for division, I'm going to look in every single numerator and denominator except for the first numerator. So I'm looking here, here, and here. Okay, so I'm going to be setting each one of those factors equal to 0 and solving to get the excluded values. So I have x minus 4 equals 0, x equals 0, and x minus 2 equals 0. So here I'll add 4. So one of my excluded values is that x should never equal positive 4. Another one's already worked out, x equals 0, so x should never equal 0. And then this one, add 2, so x should also never equal a positive 2. So I've got 3 excluded values of 4, 0, and 2, and I simplify to get 2/3. So I did copy dot flip from the very beginning. All right, next one I have x squared minus 3x plus 2 over 4x squared. This should show divided by, these are being divided, by x minus 1 over 2x. So I'm going to factor everything, and as I factor everything, I'm going to be doing copy dot flip. So x squared minus 3x plus 2 factors to be x minus 2, x minus 1, over 4x squared. I can't do anything else with. And I'm going to multiply it by the second fraction's reciprocal. So 2x is going on the top over x minus 1 in the denominator. I'm able to extend this division line all the way across, and I'm looking for identical factors in the top and the bottom. So I've got an x minus 1 in the top and the bottom. So now I have 2x times x minus 2 over 4x squared. Well, as long as your variable doesn't have anything being added or subtracted to it, you're able to simplify. So I've got a 2x in the top and a 4x squared in the bottom. So the 2 and the 4, I can simplify both by 2. So let me do that. So I'm simplifying both by 2. So the 2 is now a 1, the 4 is now a 2. And then I have an x and an x squared, an x in the top and an x squared in the bottom. So I'm going to simplify each by an x. So this x is now 1. This x squared is just now a 1x. So this all simplifies to be x minus 2 over 2x. Now, to find my excluded values, I'm going to look in both denominators and the second numerator. So I'm going to set each one of those equal to 0. So, come on, pen. There it goes. So I'm going to have 4x squared equals 0, 2x equals 0, and x minus 1 equals 0. So I'm going to put it up here. So x should never equal 4x squared equals 0. If I divide by 4, I get x squared equals 0, and the square root of 0 is also 0. So x should never equal 0. Here, 2x equals 0, divide by 2, I get 0 divided by 2, which is also 0. So still 0. And then add 1. So my two excluded values are 0 and positive 1. And my simplified rational is x minus 2 over 2x. And my last example, I have 2x squared minus 3x over x. This should be divided by 4x squared minus 9 over x plus 3. I'm sorry, x plus 5, over x plus 5. So I'm going to factor everything. So 2x squared minus 3x factors to be, I'm going to factor an x out. And I'm left with 2x minus 3 over, I've got an x in the denominator, times, I'm going to flip my second fraction. So x plus 5 on top over x squared minus 9. That's the same thing as, 4x squared minus 9. So 4x squared plus 0x minus 9. So I do 4 times negative 9 is negative 36. I need factors of negative 36 that add up to 0. So that's 6 and negative 6. So I write it as x plus 6, x minus 6, but I've got to divide by 4. Those don't go in nice and pretty, but they do simplify. So 6 is a 3, 4 is a 2. So my first factor is 2x plus 3.